The Lighting Research Center at Rensselaer and the New York State Energy Research and Development Authority bring you this video about economic considerations when upgrading to LED lighting in homes. When considering lighting upgrade options, calculate three economic metrics: the initial cost, the payback period, and the average cost of ownership. The initial cost is the upfront cost of the equipment, such as bulbs and fixtures, plus the cost of installation, minus any rebates that are received. It's up to the homeowner to decide if the initial cost is affordable. As a simple example, take this small kitchen. It has a ceiling-mounted diffuser with two 60-watt incandescent light bulbs in it. The cost of upgrading to LEDs would be the retail price of the two LED bulbs at $9 a piece or $18. In this case, there's no labor cost because the homeowner will change the bulbs. The simple payback period is calculated as the cost of the lighting upgrade divided by the annual cost savings from reduced energy use and bulb replacements. Continuing with the same kitchen example, we'll first calculate the annual cost savings. Upgrading from a 60-watt incandescent bulb to an 11-watt LED saves 49 watts per bulb. There are two bulbs in the fixture, so the kitchen will have a power demand that's 98 watts lower than before. Assuming that the kitchen is used 3 hours per day, the energy use is reduced by 294 watt-hours per day. Over a year, this will result in 107,000 watt-hours less energy used, or 107 kilowatt-hours less energy used. If the homeowner pays 15 cents per kilowatt-hour for electricity, this will result in an economic savings of $16.10 per year from reduced electricity use. In addition to electricity savings, the homeowner will also have reduced costs because they won't be replacing bulbs during the payback period due to the long life of LEDs. Assuming that each incandescent bulb lasts 1,000 hours and each bulb costs 75 cents to replace, this will result in a savings of $1.64 per year on average. As shown before, the payback period is the initial cost divided by the annual cost savings. The initial cost is the $18 for the two new LED bulbs. The annual cost savings is the $16.10 from the electricity reduction and the $1.64 from avoiding bulb replacements. Doing the division, we find that the payback period is about 1 year. After this, the homeowner will spend about $18 less per year on lighting than before the upgrade. For residential applications, calculating the simple payback period is usually sufficient, but keep in mind it doesn't take into account the time value of money or inflation like a full life cycle analysis would. Another useful economic metric is the long-term cost of ownership. The calculation should be done for the period of time that the homeowner will keep maintaining the same light fixtures. In our example, we'll use 10 years. In the same kitchen as before, comparing the option of continuing to use incandescent bulbs versus upgrading to LEDs, we find that the electricity cost over 10 years will be $197 for incandescents versus only $36 for LEDs. The initial cost for the LED bulbs would be $18 as mentioned earlier, but over the 10 years, $16 would have to be spent on replacing incandescent bulbs. Adding the electricity and bulb costs, we find that the total cost of using LEDs over 10 years is only about a quarter of the cost of using incandescent bulbs. This cost savings is based on upgrading just two bulbs. Considering that the average house has 32 incandescent bulbs, lighting provides an opportunity to save thousands of dollars over a 10-year period. Visit the Lighting Patterns for Homes website to access online economic calculators for 36 different residential spaces.